Hello and welcome back once again to yet another video in this series where I'm going to help you revise or learn Java programming and some of the programs in the BlueJ environment. So this video is going to be focused on, yes, you can see it right in front of you. It's binary search. And it's my suggestion that you already get familiar with working with arrays in the previous videos. I don't remember the video number, but get started before actually watching this video. Get started with working with arrays. Linear search, the two programs or the two videos is a must watch before you actually start watching this video. And also I would like to recommend you to watch Introduction to While Loops and Do While Loops. These are all the prerequisites. So I would just type in here the prerequisites. Prerequisites to this video are, the first one is Introduction to Arrays, and then while loops, and then do while loops. And then I would want you to actually watch Introduction to Arrays, do loops and while loops, and linear search, the video on linear search. So these four videos are actually a must before actually watching binary search. If you're say in class 9 or class 10 getting started to learn various kind of searching and sorting techniques. So watch these videos, get familiar with those techniques, and then come to this video. Only then you'll be able to understand this and appreciate it completely. Otherwise it's going to be something is happening here, but still you're not very clear about why things are happening this way. Okay, now binary search is a method to actually search or look out for an element in the array. You just want to search for an element in the array, and binary search is one of the ways of doing it. You've already seen, I hope you already seen the linear search video. So in this binary search video, it's a much faster way of searching a number in an array. It's very quick. It's very quick when compared to linear search. But there is a condition. The condition is that the array has to be sorted. Only if the array actually is sorted, you can actually search for an element in the array using binary search. If the array is not sorted, no, binary search will not work correctly. So the first thing is, binary search can work only on sorted arrays. Here we have a sorted array. The elements are already sorted. It's -1, 0, 1, 5, 8, 9, and 15. The elements are already sorted in an array. And then say we need to search an element called 1, and we store that element which we want to search in a variable called key. So I call it as a key element. I want to search the key element, and I call that element as key, and the number is 1. It can be any number. It can be 9, it can be 8, or it can be 5, or anything. Whatever element you want to search, I call it as a key element. I store it in a variable called key, which is now highlighted in red color over here. And then I have three different arrows over here. There's a yellow arrow, there's a green arrow, and there's a red arrow. I actually name the yellow arrow. I give a name to every one of my arrows. I name my yellow arrow as mid, M-I-D, the midpoint of a line, something like that. So I call my yellow arrow as mid. And I call my red arrow as high, and my green arrow as low. My green arrow is called low, my red arrow is called high, and my yellow arrow is actually called mid. So in my program there are three different variables: int low, high, and mid. And I have another variable called key, the element which actually I want to search. But I also have another variable called size. And size here is the number of elements in the array. How many elements do I have? 1, 2, 3, 4, 5, 6, 7. I have 7 elements in my array. So I initialize size to 7. And I actually keep my low to 0. I keep my low to 0, and I keep my high to size -1. What is size here? Size is 7. What is 7 minus 1? 6. So I keep my high is equal to size minus 1. I keep it here. High is equal to size minus 1. So what do I do to my high? The red arrow is my high. I actually move it to the end of the array. And what do I do to my mid? I say mid is going to be equal to high plus low divided by 2. My mid is always going to be calculated using the simple formula mid is equal to high plus low divided by 2. So where is my mid going to stay now? My mid is going to stay in what is high? High is 6. What is value of high? High here was size minus 1, which is equal to 7 minus 1, which is equal to 6. And what is mid? Mid is going to be high plus low divided by 2. That is 0 plus 6, the whole thing divided by 2. I mean 0 plus 6, yeah, 0 plus 6 divided by 2, which is equal to 3. So where do I have to move my mid now? I have to move my mid to exactly array index location number 3. Now what do I do after this? Very simple. Once I move my mid pointer, once I compute my mid pointer, the next step what I'm supposed to do is I have to check if the key element which I want to search is exactly at array index mid. What is my array index mid? A of 3. I have to check if my key element which I want to search is equal to A of mid. Right? Name of the array actually is going to be A, and mid value is going to be equal to 3, and I am searching is it equal to A of mid. Is it equal to A of mid? Is my key element which I want to search, which is 1, is my key element is at A of 3? No, it's not at A of 3. So what do I do now? Suppose if it was at A of 3, the program ends. You can just print, yes, the element is found. If my element is not found at A of 3, I have to do something. I have to check if my key element, listen carefully, is less than or greater than A of mid. Now clear? I have to check. If I find the element, I just have to print system.out.println element found. If this is not the case, the next thing what I'm supposed to do is I'm supposed to check if my key element is less than A of mid. What is A of mid? A of mid is 5. Is my key element less than A of mid? What is my key element? 1. On doing this, I'm just checking that. You know what is the value of mid? The value of mid is always where the yellow arrow actually is pointing. The value of mid is 3. If key element is less than A of mid, is checking is if my key element 1 is less than A of 3. That is 1 less than 5. Yes, it's certainly a big yes. 1 is less than 5. Yes. What do I do now? I have to do some kind of processing inside. Over here, which says if my key element is less than mid, I just have to shift my high pointer to mid. I just do low is equal to 0. Low stays wherever you stay, and I make my high, I put it to the next line, I actually just make my high is equal to mid. And what do I do now? Once I make this high is equal to mid, once again I go back and compute what is my mid. I compute my mid as high plus low divided by 2. What is my high pointer? At 3. Where is my low pointer? 0. And what is 0? I calculate the mid in the same way. I once again compute my mid. After finishing this step, I'll just get rid of this logic. After finishing this step, I'll just get rid of this thing. We no longer need this now. We have to compute a new value of mid. Once I actually finish this thing, I again go back and calculate my mid. So my new mid is going to be high plus low by 2. So low is 0, high is 3. So my mid value is going to be, like 0 plus 3, or high plus low is going to be 3 plus 0. The whole thing divided by 2 is going to be equal to 1.5. We always take a lower value, so we choose 1. So my mid is going to get moved to location number 1. So after we compute the mid, immediately we check if key is equal to A of mid. So now our new mid is equal to 1. So we check if our key element, which is equal to 1, is it found at A of mid. What is A of mid? A of mid is going to be 0. Is 1 equal to 0? Definitely not. So our element is not found. So what do we do? Is our key element lower than mid? The next thing what we are checking. Is our key element lower than mid? What is our key element? Is our key element lower than A of mid? We check. It means we are checking, is 1 less than A of our new mid. Our new mid is over here. I'll just make it appear in red, so it's highlighted. So what is our mid now? Our new mid is equal to 1. Oops. Is our mid less than 1? A of 1? Definitely not. My mid is not less than A of 1. So what do? I cannot enter inside this block. Yes. So I need another block. In my case, that is here. Let me put this open bracket over here. Yeah, let me put the comment over here. Is 1 less than A of 1? That is 1 less than 0? It's a big no. I cannot enter inside this block. So what is 1? 1 is bigger than A of mid. 1 is greater than 0. So I have to write another if block over here, which says if 1 or if key greater than A of mid. Make sense? Yes. In this case, my key 1 is certainly greater than A of mid. What is A of mid? A of mid is A of 0, because our new mid is 1. Our new mid is 1, so A of mid is going to be A of 1, which is 0. So here, key is greater than A of mid. You got that part. It's going to enter inside this block. If it's going to enter inside this block, all I'm going to do is I'm going to make low is equal to mid plus 1 and leave the high untouched. I'm not touching I, I'm just modifying low is equal to mid plus 1. What am I doing now? If I'm making low is equal to mid plus 1, my mid is equal to 1, so low is going to be 1 plus 1. My new value of low over here is going to be, equal to 1 plus 1, which is equal to 2. So when I make low is equal to 2, I just move this pointer to array index location 2. Alright, that's simple. Now, after I finish this step, again I have to go back to the first step. Say I have to again recompute my, say I would name it as, say, X, block X, or say I would name it as B. I would say make it in red. So go back to the beginning point. Go back to the beginning. So what happens after this? I go back to the beginning step over here and recompute my mid. Mid is now going to be equal to low plus high by 2. Now what is my new value of low and new value of high? Look where the green pointer is. Wherever the green pointer is, that's going to be the value of low, and wherever the red pointer is going to be the value of high. My new low and my new high is going to be 2 and 3. So my new mid is going to be 3 plus 2 divided by 2. The whole thing, 3 plus 2 the whole thing divided by 2, which is going to be equal to 2.5, but we always choose a lower number. We choose the floor value. We always choose 2. So the new mid is now equal to 2. Make sense? So where do I have to push my yellow arrow? I have to push it to my new mid. Now after this step, what do I do next again? I check if key is equal to A of mid. Don't you think so? What is our key element? 1. What is our new mid? Our mid actually is equal to 2. So what is A of 2? A of 2 is certainly 1, this element. So this is exactly where our element is found. That's it. Our program ends over here. That's all is the program. That's all is binary search. So how do we modify this? How do we certainly modify this? So everything is going to come inside a do while loop. Do, and everything, I'll just get rid of the comments over here. And I don't need, yeah, this if block is going to be over here. The whole thing is going to be over here. But what is the exit condition? This is very important. We have to figure out the exit condition. The exit condition is this operation has to keep continuing as long as low is less than high. The moment low is not less than high, this loop terminates. When would that happen? When would that happen? When would low actually be, like not less than high? Let's see that. Suppose we actually make our key to say 100. Alright, the key element which we want to search is 100. Let's restart the program quickly. Initially everything is at at the initial locations, everything at 0, and then we actually try to figure out the size and try to move the high location over here, and we compute the mid. The mid actually is going to be low plus high by 2, that is 0 plus 6 by 2, so the mid actually is going to be 6 here, and we check is mid. I'll just get rid of the comment over here. So let me keep the code intact over here, and let me open the text pad. Alright, so our new mid, our first mid is equal to 3, low is equal to 0, and high is equal to 6, and our key element here is 100. We are actually checking how to put in the exit condition. You're not supposed to just blindly memorize it. You should know why do we have low less than high as an exit condition over there. That's the reason why I'm doing a rerun of the logic with, okay, so we have this thing in our first iteration. So we first check it here. Mid is equal to low plus high by 2. So our mid is equal to 3, and low is 0, and high is 6. Now we check, is key element is equal to A of mid. What is A of mid? A of mid is 5. Is our key element 100? Is it now going to be equal to 5? Never. So what do? I check, is key element less than A of mid? What is our key element? 100. Is key element less than A of mid? What is A of mid? What is A of mid here? A of mid is equal to A of 3, which is equal to 5. We are checking, is our key element less than A of mid? Is 100 less than 5? Definitely no. So what do? We do not enter this block of code. So we go into this block of code. Is our key greater than A of mid? What is our key? Our key is 100. Is 100 greater than A of mid? Is 100 greater than 5? Certainly yes. So what do? We enter this block, this highlighted block, where we say low is equal to mid plus 1. What was the previous mid? Wherever this yellow color arrow is pointing. Now low is equal to mid plus 1. So we made this modification, low is equal to mid plus 1. and then we come outside this thing and check, is low less than high? Yes, my low is still less than high. My high is 6. My low is pointing to 4. So I continue executing the loop. I come inside here and then I make mid is equal to high plus low by 2. What is my new mid? My mid is going to be high plus low by 2. Now what is my mid? Is going to be high plus low divided by 2. What is my new low? My low is 4. Wherever the green arrow is pointing is going to be the low value, and wherever the red arrow is pointing is going to be the high value. We didn't alter high. We just altered low in the previous step. So we are going to get mid is equal to 4 plus 6 by 2. Because 4 plus 6 is 10, 10 by 2 is 5. So we are going to get mid is equal to 5. I'm going to move my yellow arrow to the location 5. So that's it. And after doing this, we immediately check if key is equal to A of mid. What is our key? Key is equal to 100. What is A of mid? A of mid is going to be A of 5. What is A of 5? A of 5 is going to be 9. We check if key is equal to A of mid. Is key is equal to A of mid? Is 100 is equal to 9? Never. So what do we do? What do we do in that case? The next step is we check if key is less than A of mid. The next statement in the program is key less than A of mid? Not exactly. What is the value of key? Key is 100. Is 100 less than 9? No. So I cannot enter inside this block. So obvious thing is I have to check this condition. Is key less than A of mid? Yes. Key is 100. A of mid is 9. Is key greater than A of mid? Definitely yes. Key is greater than A of mid. So what do? I just make low is equal to mid plus 1. I make my low is equal to mid plus 1. So my new low is going to be equal to 5. Right? My new low is going to be equal to 5. And my mid is again going to be equal to, let's compute that. Once I make low is equal to mid plus 1 over here, low is equal to mid plus 1. My previous value of mid was where exactly the yellow arrow is pointing. So my new low is going to be mid plus 1. So you see, my green arrow is actually going to be the same place where the red arrow is pointing. Both of them are actually pointing to the same location called as 6. See, my low is now going to be mid plus 1. My previous value of mid, my previous value of mid was 5, and my new value of low is going to be mid plus 1, which is now 6. How do I compute the value of mid now? How do I compute the value of mid? Mid is going to be high plus low divided by 2. You know what? What's going to be mid now? Mid is going to be equal to 6 plus 6 divided by 2, which is going to be equal to 6 again. So what is going to be the position of this yellow pointer? At 6. So I now check, is key element is equal to A of mid. What is A of mid? A of mid is A of 6. Alright, what is A of 6? 15. I'm checking, is my key element equal to A of mid? No, my 100 is not equal to 15. So what do? I check the next condition over here. Is key less than A of mid? Definitely not. What is key? 100. What is A of mid? 15. Is 100 less than 15? No. I'm going to come inside here. Is key greater than A of mid? What is my key element? My key element is going to be 100. Is 100 greater than A of mid? Is 100 greater than 15? Certainly yes. So I enter this block, and what do? I make my low is equal to mid plus 1. So what will happen to my low? Low is going to be mid plus 1, which is 7, and it's going to come out of this if block and check the exit condition here. Is low less than high? This is where our exit condition proves to be wrong. See, low is 7, high is 6. Low is not less than high, so we exit out of this entire do while block. We no longer execute this do while block. We don't need this. We don't need this part. See, that's it. So we exit out of this do while block, or this do while loop is no longer valid because this condition failed, as a low is no longer less than high. So this program will continue only as long as the low pointer is positioned, this low pointer, the green pointer, only as long as it is positioned less than the high pointer. This program will continue to run. The moment the low pointer's value is more than the high pointer's value, it means that we have exceeded the array. In our previous run, what happened? A low crossed high. So low was almost here. But does it make any sense? It's going out of the array. It means we have completely searched the entire array. If this low is going more than where exactly this high pointer is staying, it means we have searched the entire array and we haven't found the element. So there is no point in continuing the program, because outside the array you're no longer going to find out the element. That's when the program stops. So instead of actually printing element found, what we can do here is we can set a flag variable. Flag is equal to 1, and then we can break out. If we actually find the element, suppose if we found the element somewhere inside, we don't have to do any more searching. That's when I actually set the flag element to 1 and break out. So after I come outside the while loop, I can just check for flag statement. If flag equals to 1, then print the element is found. Else print, not found. This thing can be done. So instead of me actually printing the message here as element found, I'm just setting a flag variable to 1. Initially, I would actually have a local variable by the name int flag is equal to 0. Right? When the element is found, set the flag variable to 1. We don't have to search further if an element is found. So we break out of the while loop. And then after the do while block, we check what is the condition of flag. If flag is equal to 1, it means we have entered this block. It means we have found the element. If flag is equal to 0, it means we have never found the element. So we are going to print element not found. So let's see the working code for that. I don't need this. I'm just going to close it. Yeah. This is how the working code is going to look like. I've just declared an array. Mind you, the array has to be in sorted order only. This doesn't work on unsorted arrays. Binary search will not work on unsorted arrays, and preferably I have kept it in ascending order. You can also make a small modification of the binary search even if the elements are arranged in the descending order, but this logic is preferably for elements arranged in ascending order. So I'm just initializing the array elements over here. I'm keeping low to 0, and I'm keeping mid uninitialized because I'm computing mid over here inside the loop. I'm keeping flag to 0. I'm keeping the size to 9. How many elements do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. The number of elements in the array is going to be stored in a variable called size. And then high is always equal to size minus 1, which we already discussed over here. See, high is equal to size minus 1. So I'm keeping high is equal to size minus 1. And then I'm just printing the array elements. I'm just printing the array elements for the user to see what exactly are the array elements. And then I'm initializing my key element to 31. I'm initializing my key element to 31, and the rest of the code what I've written here is exactly same what you could find in this WordPad. This portion is exactly same, a copy paste of whatever you can see here. And then after the while loop, I'm just printing a new line. I just want to keep the output separate. And then I'm actually checking the flag. If flag is equal to 0, what does it say? We have never entered inside this block. We have initialized flag to 0. If flag is equal to 0, we have never entered inside this block. It means element is not found. So I'm telling the key element is not found. If we have entered inside this block, it means we have found the element somewhere, and we have set flag to 1, and we have given a break statement. What does a break statement do? A break statement exits out of this while block altogether. we don't do any kind of searching or any kind of processing once we execute break. Break is to completely stop this while loop and come out of the while loop. If we found the element, we are setting the flag to 1 and we are breaking out of this while loop. That's all we do. And once we break out of this while loop, flag value will be equal to 1. If it is not equal to 0, definitely flag is equal to 1. If flag is equal to 1, it means we have found the element. We just say print the statement like we have found the element. That's all we do. Let's compile it. No syntax errors. Close it. We can minimize it for time being and call the main function. Let me clear the output of the previous runs and let me recall the main. See, element 31 is not found. The original array elements are 1, 2, 3, 4, 5, 6, 7, 8 and 9. I entered 31 as a key element. 31 is not found. Clear it, close it. Let's go to the main and let's actually give an element called say 3 instead of 31. Let me give 3. My key element is 3. Certainly 3 actually is found in the original array. So we have to get the output as 3 is found. Compile it, close it and say call the main. See, element 3 is found. As simple as that. So clear the output, close it. You can also make a small modification in this program to figure out where exactly the element is found. Where exactly is the key element found? When you break out, whatever is the value of mid is exactly the position of where the key element is found. So if you actually try to print found at, the key element is found at location, plus mid. If you try to print what exactly is the value stored in the variable mid, that is going to be the position of the element which you are trying to search. Well, let's run it. See, the element 3 is found at location 2. Why location 2? 1 is at location 0, 2 is going to be at location 1 and 3 is going to be at array index location 2. You have to start counting from 0, 0, 1 and 2. So 3 is found at array location 2. Clear it? Now let's actually give another number. Say let's actually clear this, close it. Let's actually search another number. Say let's search 8. Let's search 8 and see what's the output. Compile it, close it, call the main. See, it's found at location 7. 0, 1, 2, 3, 4, 5, 6, 7. It's found at 7. Let's rerun the program and see if, let's actually try to give, clear this. Let's actually give a number called say 800. It's not found. 800 is not found. Or let's actually give -5. Let's give -5. Compile it. Close it. Call the main. See, element 5 not found. Element is not going to be found. Clear it. Close it. Hope this program is clear. So hope you can understand this program with the help of this video. So don't expect that you watch the video once and you understand this program, bam, in just one go. This is not like watching a movie. Like you watch a movie, end of the movie, it's like, oh yeah, I understood the movie. Except it's going to be like, a complicated science fiction movie which you have to watch it for almost like 4 to 5 times to understand the movie sequences. And this video in programming, especially where I've tried to explain the hands-on working code, don't expect to understand the complete working of the program in one go. You might have to pause the video in several locations, rewind them. You have to have a piece of pen and paper in your hand. Like try to do a dry run by yourself. And then you have to practice the code. So if you do all these things, it might take a couple of hours to get a complete and thorough understanding of the working of this program. And once you have the working of this program, mind you, you don't have to memorize any program. It's a very, very bad practice among the school kids. Like you keep memorizing programs. Don't do that. Programming is just like math. You don't have to memorize math. You don't have to memorize to write program. You just have to understand how it works and you can write it by yourself. So this whole attempt of trying to explain this in such a detail is to ensure that you enjoy programming by understanding them and not by memorizing them. So hope you find this video useful. So watch it time and again, pause them whenever needed, and then start working on this program, start writing your own code, and that's when you're going to enjoy programming. So you're not going to learn programming by someone teach programming or someone write programs. So that's it for now. See you again in yet another video. Goodbye.